Okay, so next thing we're going to look at is antenna placement. So antenna placement is important. They should be placed up as high as possible. This helps to improve the line of sight over the horizon. On vessels, it is near impossible to avoid all blockages. If you've got two antennas, 50 centimeters either side of, say, a 20 centimeters diameter mast, that would be sufficient. However, if you have antennas located either side of a much larger mast, then this will cause a blockage and should be avoided. Antennas should be at least 50 centimeters apart. So on 1800 megahertz, that's how far apart they need to be at a minimum. If you're expecting to use the bands around 900 megahertz, they should be at least 90 centimeters apart. So the best thing to do is just aim to go at least 90 centimeters apart on each antenna. So by locating the antennas apart from each other, what we're trying to do is create diversity paths between the antennas and cellular masts. For short applications, diversity paths are usually created by bouncing off the surroundings. At sea, your surroundings are much more uniform. So by using vertical separation, you're able to create different paths by bouncing the signal off the sea. So antenna selection. So omni versus directional. Omnidirectional antennas give you a 360-degree view of the surrounding RF environment. Think about the pattern like a donut. A directional antenna is designed to be pointed in a particular direction. Think about this RF pattern more like a cone. With an omnidirectional antenna, when the gain is increased, the beam width is reduced. Think of it like squashing the donut down. So you should get a longer range, but what this is going to do is make your setup more susceptible to loss of signal if the vessel is rolling. So you can kind of see that in the bottom right image there. It's showing how the beam width kind of gets squished down and extended further out. It will give you longer range, but it's not going to be as wide on the beam width. Okay, so the next thing we're going to look at is power dividers and power splitters. So a lot of people ask me if it's okay to use these. So power dividers do exactly that. They divide the power. If you have an HD4 with two antennas and two 4-in, 1-out power dividers, you're going to be getting less than 25% received signal on each modem. Now think about how that will affect your range at sea. I've seen vessels which were using two antennas and power dividers on an HD4. They're only getting about 4 miles offshore before losing connectivity. When we removed the power dividers and installed antennas, additional antennas, the vessel was easily able to get 20 miles offshore and still remain connected. So another question, directional antennas are recommended for large cruise ships and tanker ships. Is this statement A, true, or B, false? Okay, so the answer is B, false. So the yacht Latitude, they had a BR1 Mark II. It was an LTE version, which supported 4G in Europe and USA, but this wasn't enough. They were suffering from brief drops in disconnection and connectivity due to relying on a single cellular model. This install has the router located directly beneath the antennas, which allows for a very short cable run. We also implemented speed fusion, which allowed for brief cellular outages to be no longer noticed by the end user. So with the final setup on there, they were able to get 10 megabytes per second upload and download per modem at 50 kilometers offshore.